This is where we left off, cast operators. We learned that conversions will happen in two different operations. When you assign value to variable, if the variable type is different from the value type, then the value will be converted. Also, within an arithmetic operation, if the two operands are not of matching type, then both will be converted to a higher level, to a larger type. And then the operation will be carried out. Those are conversions. Now, sometimes we need to convert manually. We need to do a manual conversion of our data temporarily for an operation to work right. In a certain arithmetic operation, if I want to get the value computed correctly, I need to temporarily change it. So I'm going to go back to a previous warm-up exercise to illustrate. Let's say I have int m equal to 9, int n equal to 2. They are both integers. And if I do float s equal to m over n, it will not produce the right results. Because when you divide 9 over 2, it'll be 4, not 4.5. Because integer divided by integer is integer. So it's going to give you integer part of the answer. And when you assign it to s, it'll change, the 4 will change to 4 point. That's all it does. Having a float type variable on the left side doesn't mean this division will produce float type answer. It's not going to. So therefore, you will have a 4 coming out of this division. It will be converted to 4 point when you're storing it as, and which is its wrong answer. So that means, you know, there is, if you want to get correct answer, m or n needs to be float. Only then it'll do correct answer. But there are other reasons, you know, this may be a long program, this may be part of a long program, and you want this m to be int for the rest of the program. So you don't want to make it float, and you don't want to make int float. There are reasons why they have to be int. So is there any way I can make this division work right without having to change my data type of m and n? Yes, you know, that's obviously a situation that you can run into. So the C++ language has a way to handle that, and that is what cast operator is. The cast operators are basically the keywords of the data type in parentheses. So if you put float in parentheses like this, that becomes an operator that'll convert whatever that is written next to it to float type. So if I write float 35, 34, this will be same as 35 point. But you don't have a reason to write float in front of a number like that. You can instead put a decimal point. So we normally need this operator only when we are using it with a variable. So going back to that warm-up exercise, so what I need to do here is to make this division work right. In front of m, I put this float in parentheses. So now what I'm saying is convert the value of m to float and then divide by n. So value of m, the variable m remains integer. Just for this operation, the value of the m will be converted to float, and then the division will be carried out. So this division will be now done as 9 point divided by 2, which will be 4.5, and the answer will be correct now. It'll be 4.5. In the earlier version, without the float, the answer was 4 points stored in S, which is wrong answer. So that's why this operator is there, to handle situations like this. You don't want to change the data type, but you want to make the operation work right. So you throw in the float. So here are some examples. If I write float 3 divided by 2, that'll be same as 3 point divided by 2. So it'll come out right. Division will be right. But you know, you don't have to use float in front of 3. You can just change the 3 to 3 point. So float is not used in this kind of situation. So here's another example. int KLM, KLM as integers, DE are float, K is getting a 7, L is getting, we are assigning 3.5 to L, but L is integer type, so it's not going to hold 3.5, it's going to hold 3. So this division K over L is 7 divided by 3. 7 divided by 3 is 2. Since both are integers, K and L are integers, this will only produce 2, the integer 2. And when you assign it to D, it'll be converted to 2 point. So D will have a 2 point, which is wrong answer. It's not the correct division. But if you divide it, if you put the float in front of K, then float K will be 7 point, and you're dividing it by 3, and that will be 2.333. What if you divide it by float L? That will be also correct. Only one of them needs to be float to get the right answer. So now the division will be right, 2.333 will be produced, but then you're assigning it to integer variable, so you're only going to pick up the 2 in M. These are just to show you different situations, what will happen. The first one is not going to produce right answer. The second one will produce right answer, assuming you wanted to divide by 3. You're dividing by 3, not 3.5 though. So if you wanted to divide by 3, this division will be right. Here the division is right, but you're assigning it to integer, so you're not getting the right answer. So the first value of the D has 2 points, and E has 2.33, K has 2. These are the numbers printed by this program. So this can be a homework homework question that says, write exactly what will be on the screen, what will be printed. Then this will be your answer right here, what I have highlighted. Do not write L equal to this, D equal to this, unless that's how the printout will come out. If it says write exactly what you expect to see on the screen, you only write what the program will produce. This is all it's going to produce. It's not going to have D equal to E equal to and all that. So if you write other things, then it's wrong answer. Okay, moving on. The cast operator can be used in front of any variable. Even at the print statement, you can do it, even at the cout statement. So here's an example, float A equal to 4.85, cout int A. So you're saying print integer part of the answer for me. And so that'll print only 4. So basically you're converting A to integer, which is same as picking up the integer part. So that'll print A. You can convert at cout like this, int n equal to 66, n1 equal to 66, cout char n1. Char n1 means you're converting n1 to character. You stored an integer and now you're getting it printed as character. You can do that. So the printout will be B, capital B. As you remember, 66 corresponds to a letter B. So that's what you're going to get. You can store an integer and get it out as character. Store a character, get it out as integer. All those conversions can be done at the cout statement. Okay, so here is my title is missing for some reason. Basically, what we want to do here is the order of precedence. In what order arithmetic operations will be carried out by the system. That will matter because it depends. That's exactly what, there are certain rules the system will go by as to which operation will be done first and which will be second and so on. And so we need to understand those rules so that we will write the program correctly to produce the right answer. So to show you that, here's an exercise. Actually, I'll do that as an example. A, B, C, N are float, and A is getting a 10, which will be actually 10 point will be stored there. B will be getting a 2 point stored, N will be 5 point. And if I do this expression and assign it to C, which operation will be carried out first, the division or multiplication? That's our question. If it does the division first, then it'll be 10 point over 2 point times 5 point, which is 25 point. But if you do it the other way, if you do the multiplication first, then it'll be 10, B times N is 10 points. So you're dividing 10 point by 10 point, which is 1. As you can see, if the order is different, if the system does the operations in a different order, then your answers will be different. So exactly what you intended has to be properly translated to C++. Only then you will have the right answer. So if you don't put parentheses around, then the system has to follow certain order. It has to make the decision as to which operation to carry out. So the system has been given some instructions as to what operations should be done first if there are no parentheses. Of course, if there are parentheses, it has to follow that. The parentheses has to be first. So let's understand those, the order of operations next. So here is oops. All right, here's the order of operations. Parentheses will be always done first. And after that, unary minus will be done. Unary minus, I need to explain that. If you put minus in between two numbers or two variables, that'll be subtraction. If you put minus in front of a number, that is called unary minus. It's making that number negative. And this minus operation going in front of a number can be used to used in front of a variable also, like this. I can write in an expression minus m times n plus k. That means I'm saying here, take the value of m and negate it, make it negative, then multiply by n, and then add k. That's what I'm saying. So this is called the unary minus operator. Just like we write minus 5, we can write minus m also. So that unary minus will be next after the parentheses. If there is any unary minus, it'll do that. After that, it'll do multiplication, division, and modulus. These operators are, all three of them fall into the same level of precedence. But if there is more than one, very often we have a division and a multiplication in same expression. So it'll do left to right if there are more than one of those. Similarly, if the plus and minus will be next, and again, if there are more than one of those, it'll do left to right. So with this, let's go back to our previous example. Which operation here will be done first? And what will be the answer?
So you would do B times N first?
No, I just went over that. You have a division, you have division and multiplication. Division and multiplication belong to the same level of precedence. So if there are more than one of those, it'll do left one first. Remember, I said that, right? So the division is on the left. So it's going to do that first.
So it's 10 divided by 2 first, 10 point divided by 2 point first.
Right, 10 point divided by 2 point first. Then it'll multiply by 5 points to get 25 points. So it's not going to do it this way. It's going to do the division first because of that instruction that if there are division and multiplication in the same, in an expression, if there are both of them, then do the left one first, whichever is on the left first. Okay, so that's, so it'll do 10 point over 2 point times 5 point. Okay, and similarly, minus these operations, plus and minus, if there are more than one of them, it'll do the one on the left first. Remember that. All right, so let's see examples. So here is an example. Warm-up exercise actually. So A is 24, B is 6, C is 4, and they're all float, so there will be no conversion. Can somebody tell me what will be the value coming out of this expression stored in G? Or what will be printed, basically? You can work it out quickly on a paper, use calculator if necessary. You have to follow the order of precedence.
Um, 20.5.
20.5 is incorrect. Try again.
Is it negative 3.5?
Negative 3.5 is not correct either.
Is it negative 11.5?
Negative 11.5 is correct. Very good. Negative 11.5 is the correct answer. Now I'm going to show you why. Which operation is going to be first?
E minus F.
E minus F, because there's parentheses. And E minus F is a 2. So that slash 2 will be carried out first. You know, it's not going to make much difference, but that's the first one. So we have this division by 2. And then the next operation is the negation. Unary minus negative A is next. So negative A is going to be negative 24. All right, so that's done. After that, you have the plus will be the last one, right? So don't pay attention to that until you do everything else. Which operation is next? I have negative 24 here. What's the operation next?
Negative 24 divided by 6.
Divide by 6, that's right. Which will be negative 4. So I have a negative 4 coming out of this. Which operation is next?
Multiplication.
Multiplication by the C.
Yeah.
Yes, multiplication by C is next. And that will produce a
Negative 16.
negative 16. Okay, so going to the board, I have negative 16 coming from the first. And now I have a D, which is 9 over 2, 9 point actually over 2 point, because they're both floats. So that's 9 point over 2 point. So negative 16 plus 9 point over 2 point is 4.5. So that will be negative 11.5. Okay, so
Professor, where'd you get the 4.5? I got stuck after. Wait, what do I do with the 2 after the E and F? Is it still in the parentheses?
yeah,
wait, never
E
mind.
minus F in parentheses will be evaluated first. So it'll be replaced with the 2 point, right?
Oh, okay. I just saw the slash. I didn't realize it was was it 9 divided by 2?
Yeah, 9 divided by 2 point. 9 point divided by 2 point. Remember, if you keep those points with them, then you won't lose them. You won't lose the point. If you miss the point, you may end up with the wrong answer because remember 9 over 2 is 4. 9 point over 2 point is 4.5. Okay.
Wait, how's it oh, is it negative because of negative 24?
Yes.
Okay. Thank you.
The negative A times negative A is division B. That's negative 24 over 6. And that's negative 4. multiplied by C will be negative 16, right? So that's why this number is negative right there, negative 16. And then here it's a 9 point divided by 2 point, which is 4.5. To keep yourself reminded of the point, you know, of the fact that they are float types, you know, you should use the decimal point with the number. So the D here is 9 point, E minus F is 2 point, and therefore 9 point over 2 point is 4.5, and therefore 11.5. All right, we don't need the next exercise. We'll move on to, yeah, we are finished with the 2.3. So the remaining even numbered problems from 2.3 will be part of your next homework. And moving to, sorry, 2.4. Let's see, it's about input through keyboard and interactive programming. That's our topic now, interactive programming. And let's understand the need for it. The way we wrote program in the last project, you know, the last project was just a very elementary project given to you just to get started and understand how to work with this compiler and all that. So now you have done that. Now it was nice to see that 90% of the class had 100% on that project. Only a few people missed things. Things like, I mentioned to you when I was explaining how to turn in the program, I mentioned to you that you should always write a comment block explaining what the program does, even if the program is very elementary. It's a habit that you have to develop, and that's why they are requirements. You need to write a block explaining what the program does, and you need to have another comment which will be your name. And always, when you produce the answer on the screen, there must be a descriptive text explaining what that answer is. And otherwise, just putting a number on the screen is not helpful for a user. Your program may be used by others, so things should be very clear for the user. That's why those are requirements. So some students lost points by not putting their name as a comment or not writing descriptive text as part of the output, things like that. That's how some students lost some points. But most of you got it 100% right, which is good. So let's understand why the way we wrote program in that project is not acceptable. We have to move on to interactive programming. And so I'm going to explain why. So let's look at this simple program of adding two numbers. This program will add number 23 and 35. So to write that, I store 23 in a variable and then 35 in a variable, introduce the variable sum, and then all you have to do is sum equal to num plus right, and then sum of the given numbers is sum. All right, so that'll produce the answer. Okay, so that program will add the two numbers. Now, what is bad about this program is this program can only add 23 and 35, nothing else. So if I want to give this to someone, and say this program is valuable, it's not valuable. Why? Because it can only add 23 and 35. But the others who want to use this program don't want to add 23 and 35. They have their own numbers to add. So if they want to use this program to add their own numbers, then they have to go into the program and change this number to one of their numbers and change this number to the other number, and then run the program. Then that means you're expecting the other person to know how to modify the program. Well, expecting the other person to know how to modify the program is not a good way to build a program. It's like building a car, but the other person has to know how to modify the mechanism to be able to drive himself. That's not right. The other person should be able to drive the car without having to know anything about the mechanism. So we want to build something that's useful for others, then make it useful for everybody without having to know how to modify. Others should not have to learn programming to learn how to, and then modify the program to work for them. That's not right. So how do we do it then? We have to come up with a better way. And the better way will have to be this way. When the program runs, the program should be able to, we should be able to write the program without the data built into it. Instead, when the program runs, it should ask the user for the data that he or she has. It should work for their data, not your data. So it should ask the user, can I have the data? And then it should go on to produce output for those data. That's the right way. So that's the kind of programming we call interactive programming. The data will be obtained from the user at the time program runs. Okay, so how do we do that? C++ language gives you this cin operator, cin object to get data from user. So you write the cin with the arrow. Now remember cout was written similarly, but cout was written with the arrow pointing the opposite way. So if I write cout like this, and then a variable name val, that means write the variable value of the variable val on the screen. And if I want to write cin, then the arrow goes the other way. And any variable name you write next to it is a variable name where the value will be stored. So now you're storing value, you're not printing value. So this is input as opposed to this being output. That's output, this is input. So how does it work? When this statement, if you have a statement like this in your program with some variable name, then when that variable is executed, when that statement is executed, the cin val, for example, when it is executed, the system will stop right there. It won't do anything. It'll just wait for the user to enter a value. So user has to enter a value at this point. When this is executed, user must enter a value, and then he will have to press the enter key. Only when the user presses the enter key, it will take that value and store it in here. So it is reading from keyboard. Whatever you're typing on keyboard is being read. And that value will go into this variable, and then it will go to the next line of the program. It won't go to the next line of the program. It'll be stuck right here until user enters a number or character, whichever the data expected. That's how it works. So the user can enter his or her own data when the program runs. If the data type, by the way, doesn't match the value entered by the user, then the value will be converted to match the data type. So if the data type is integer, it can only hold integer. If the user types a float type number, it'll convert the float type to integer and store it. Okay, so let's see how to put it in a program. In a program, here's a simple example: int num1, cin num1. So when this is when this program is executed, when this line, when the program, the system is executing this line, it'll wait right there for the user to enter a number. And let's say user enters a number and presses the enter key. When he presses the enter key, it'll go ahead to the next line. Now it'll store the number entered by the user in the num1. Now we'll go out to the next line, which says cout num1. So it'll print that same number on the screen. So whatever the user entered will be printed. So it's just a simple program to show you. If the user entered a 3.54, the variable is integer, so it will only have 3 stored in it. And so it'll print the 3. So if you run this program and type 3.54, it'll print 3. So that's how it works. But one big problem with this is, let's say you give this program to someone and say, yeah, this program will print whatever number you type. Okay, so that person will execute the program. When he or she executes the program, nothing is going to happen. Why? You know, the computer, the black window will appear. You're going to write it as a console program. The console program will bring up this black console window, and that's it. Nothing will happen. The console window will be black and nothing will be showing. Why? Understand what I'm talking about? Nothing will be happening because the system executed all these lines, and when it came to this line, it's waiting for the user to enter a number. But the user doesn't know. You know, the blank screen is there, and system is waiting for the user to enter a number, but the user doesn't know it's waiting for the number. That's the problem. So only if he or she enters a number and presses the return, it'll go on. So this is clearly a problem. When the program runs, it is going to wait for the user to enter a number, but the user doesn't know that. So there must be some way we can let the user know. Otherwise, it's not going to work. So is there a way? Yes, we can actually, let me go to that part. We can actually make it, we have a solution for that problem, which is right before the CIN statement, if you write a cout statement, which will put a string explanation on the board. Remember, with the cout statement, anything you put in double quote will be written as is on the screen. Anything you write with the double quote in the cout statement will be written as is. So if I throw in cout statement, that will put a text on the screen explaining to the user what is being expected, then that'll work. That's the idea. So here is how you make it work. You write in the, I'm rewriting the program that adds two numbers, but this time I'm writing it in a better way. I write this cout statement will put a text on the screen. And when this text is on the screen, system is here. It has already executed this line, which will put that text on the screen, which is enter an integer followed by return. When that is on the screen, system is waiting here to get a number. So user knows that it's waiting for a number, so he will enter the number and press the enter key. When he or she presses the enter key, it will take that number entered on the keyboard into this variable, and then it'll go to the next line of the program, which will execute this, and that will put that text on the screen, which says enter another number. And then system will go here, and when the system is waiting here to receive a number, user already knows because it tells him or her that we are waiting for a number. And so the user will enter a number, and that number will go into this variable now. And then the system proceeds to do this, which will add the two numbers entered, and now it's writing the sum on the screen. So now it looks like the system is interacting with the user, but it's the programmer who makes it happen. The system is interactively getting the data from the user and producing a result. So now this program is good for adding any two numbers for anybody. So our goal is to write program that's useful for everybody. So that's why we have to make it work this way. Now there is, I have this \n at the end of that text because I wanted the cursor to go to the next line after putting this text, so that whatever the user enters will be on the next line, not on this line. You don't want the number to go right next to this text. So that's why I have the \n right there and a \n here. So if I run this program, what will happen on the screen? This is what's going to happen. But I wrote it as if it happens on the regular screen, but we are writing console program. So this will be happening on a console window. The black window you have seen in the last project, that black window is where this interaction will happen. So this text will appear on the black window, and the cursor will be then waiting on the next line. Because of the \n, the cursor goes to next line and waits there. And that's where the user, whatever user enters will go. So whatever user enters on the keyboard will appear on the screen as well. And then he or she is going to press an enter key, and that enter key will make it go to the next line. And that's where the next text will be printed like this. And after printing that, the cursor will go to next line because of this \n. It goes to next line and wait. And there, the second number will appear. The user is entering second number, and that will appear on the next line. When he or she presses the enter key, now it will go on to do the sum and then print the sum. So on the very next line, you're going to see the output right there. So this is how the interaction goes. So it looks like the computer is interacting with the user, but it's actually the programmer is making it work like that. Okay, so that's how you write the interactive program. Now, sometimes we need more than one data to do whatever we need to do. So if we can do it this way, we can write one cin statement, and when that is executed, it'll wait for one number, and the user will enter the number. When it'll get the number and store it in num, and then it'll execute this line, it'll wait again. Now, of course, you have to tell the user every time it waits. I'm sorry, we did do that in our program. We did get two numbers, one after the other. So the point I'm trying to make is, do I have to do this in two separate interactions, like enter one number first and then enter second number? Can I get both numbers in one line? Yes, you can do that by writing cin statement this way. If you write it this way, then user will be able to enter two numbers at the same time, separated by a space. So the user will have to separate them by space. Otherwise, the whole thing will become one number. So when you write that instruction, you have to say, enter two numbers separated by space. Only then this statement will be able to read them. So here's the modified version of the program. I want to get two numbers from one cin statement. So here's my cout statement that tells the user to enter two numbers. Notice that the instruction I'm writing on the screen is too long to fit on one line, so I'm breaking it into several lines. If you break that into several lines, there had to be individually double-coded lines. Individually double-coded lines with arrows, separate arrows. That's the only way. You cannot write a whole paragraph with the double quotes, unfortunately. You cannot break it up. So if you're breaking it up, you write them as separate strings. That's one string, and this is another string, and so on. The double-quoted text are called strings. So you have to separate them into several strings. You cannot write them all as one string. That's one thing you need to remember. So this says enter an integer and a floating point number separated by a space, and then press enter key and all that. You have to give the full instruction to the user. So now the cin statement can read two numbers as long as the user separates them by space. And then it'll add those numbers and it'll print the sum. Now, not only two numbers, if you want to get five numbers, you can write five variables listed this way. But you have to tell the user to separate them by a space. That way you don't have to write five different interactive lines. You can write one line or one set of interaction like this. These two will take care of all the data. And then you proceed to do the work. All right, so you have, that's our interactive programming. I'm moving, next thing is something else. But the point I'm trying to make is your next programming project is interactive programming like this. And I forgot the program number, project number, but your course calendar tells you. And also I'm going to create the link for it. So when our class finishes this afternoon, I'll create the link for the project. So this Monday, you have the project and homework due, but you have 5 days to do it. And the project is not that long, it's short, but this time it's a little more serious programming than the last one. You're writing an interactive program that'll work with any numbers the user has. So the assignment includes the ones from the last section 2.3 that was skipped, and also the 2.4. I will put those numbers exactly, the exact numbers that you have to turn in at that link. All right, so let's understand constants in a program. In programs, sometimes we have to create constants. Constant would be the mathematical constants like pi. If you need pi in your program, you have to provide this value. The system doesn't know the value of pi. Computer system, in the calculators, you press the pi button, you get the value, but that's because the calculator already has a program. The computer by itself has no program to begin with, so none of these values are stored anywhere in the system. So you have to provide them in your program. But when you provide the value 3.1415 as pi, you need to store it in a name. You cannot use this symbol as a name. No special symbol can be used as a variable name. So you can use a name like pi, pi, and store that number. Similarly, if you need this number, e, then you store it in a variable e and use it in the program. So let's see a simple example program where you use that. This is a program that will find area of any circle whose radius will be entered by the user. So it'll, whatever the radius user has, it'll get that radius and find the area of the circle. So to find the area, I need pi. So therefore, I introduce that as a variable. I declare the pi as a variable and store that number. And then radius, area are additional variables. Then you ask the user to enter the radius, read it into radius, and sorry, that's not supposed to be there. So if you now compute the area, it's pi r squared, pi times radius. That's how you translate that in C++. Put that in area and write the answer on the screen. Excuse me. So that program will get the radius from user and compute the area for that radius and put it on the screen. So it's useful for anybody to find area of any circle. The problem we wanted to discuss here is having the pi declared as a variable here. If you do that, there's a certain risk that this pi can be accidentally changed in this program somewhere else. Now, in a small program like this, the accidents don't happen, but in real life, professional programs, they are pages and pages long. And so the user may introduce the pi at the beginning, and then the programmer can introduce the pi at the beginning, and in some place else, he can end up creating another name with the same variable, same name. He can create another, thinking that he or she hasn't used that name, introduce that again and store another number, or increment it by 1, pi plus 1, something like that can be accidentally written. What does this mean? To the current value of pi, add 1, put it back in pi. So that will be changing the value of pi here from 3.14 to 4.14. So the pi has been changed accidentally. Since this is a constant, we know that this pi should never change in the program. It's a mathematical constant. So we may need this pi over and over in this program. We can use it over and over, and we need to make sure it doesn't get changed accidentally. So this kind of statement should not occur anywhere in the program. So can we guarantee that? Can we make sure that pi will not be changed accidentally by the programmer? Yes, that's a feature we call const. The keyword const, if you introduce that keyword and put that in front of this const, then that tells the system that this pi will remain constant throughout this program. It should not be changed anywhere. So if that is declared as a const, then this statement will be recognized as an error by the system. The compiler will reject this program. The program will never run, and it'll say this line is a problem because pi is a constant. So we want that kind of warning. We want the program to recognize this as an error. We want the compiler to recognize this as an error because we don't want the pi to be changed. That's why we introduced that keyword. So the keyword const will make sure that the constant, the value we are storing there, will remain throughout the program. It'll never get changed anywhere in the program. That's why we do that. So how do we exactly say that? By putting the const keyword in front of it. So const float pi. We use uppercase letters whenever we use constants. If you remember, when I explained the rules for variable names, I said lowercase alphabets only, no uppercase alphabets in a variable, because uppercase alphabets are used for constants. So when you name a constant, you use uppercase. Why do we do that? Because this way, anybody reading the program, whenever he or she is reading an uppercase name, he or she will know that that's constant. So throughout the program, we make sure to write that name with the uppercase letter. The C++ language is case sensitive. So if you declare it as pi with the capital letter P and I, then lowercase pi will be a different name. So you have to use the same uppercase letter. So the reason for uppercase is to highlight the fact that it's a constant and it'll never change. Okay, so when we are actually using it in a program, there are two ways to declare a name as a constant. This is one way, const float pi equal to this. And another way is to write pound define. At the top of the program, we write these instructions with the pound, therefore preprocessor. I explained that, therefore the preprocessor. Preprocessor is a part of the processor that will be processing all the instructions that begin with pound. And it'll be bringing in all the libraries that you're asking for and doing all those things. And that preprocessor will recognize the pi as a constant if you write it at the top. Notice that there are no equal signs here, just space. Pound define, space, pi, space, number. That's how you write it. And if you write with the pound define, you have to put it before the main. All the pound instructions have to go before the main. So I'm going to show you an example in a second. You can use the const qualifier that inside the main. If you use const qualifier, then that'll have to be inside the main. If you use pound define, it'll have to be outside. So if something is declared as constant, the value can never change. If any statement is changing the value, the compiler will not compile the program. It will complain the line is invalid, the line that changes the constant. So here are the two ways to put your constant. One is pound define pi at the top before the main. And this program, as you can see, is using pi in here to find the area, but the pi is defined outside. As long as it's a pound defined, it can be defined outside. But in this other method, we are declaring the pi as a constant inside using const qualifier. So this const qualifier can only be used inside the program within the main. Pound define will be before the main. Either way, pi will be recognized as a constant and it can never be changed. Any statement that changes pi will be identified as an error and the program will not compile until you change that. Okay, so warm-up exercise. It says using a constant value 0.08 for 8% as the annual rate, write a program that'll have the system obtain the current balance in the savings account. So the user will enter the current balance. Then your program will compute the new balance after adding the interest, and it'll print that new balance on the screen. Okay, let me see if you can write it. You can type it in the chat or show it to me by putting it against the camera. Anybody has the program? Okay, I see it's 2 chats. So let me check. Yeah, that's just one statement, but you have written, but I need to see the entire program. The program will have to, I just got started on the board, you can see. It'll have to begin with the main and then declare the variables, constants, all that. And it'll have to get data from user and then produce the output. All that have to be done. So I declared my interest rate as a const float rate equal to 0.08. If you want 8%, then you had to multiply by 0.08. So I declared 0.08 as my constant. But there is more to write. Anybody has the complete program can show it to me. All right. All right, let's work together then. I have main program. I have the program on the screen, part of the program. Float BAL. BAL stands for balance. Whatever the account balance is, we can have to store that here in this name. And rate is a constant where the interest rate is there. What should be next? Our goal is to get the balance, current balance from the user, and then calculate new balance and print it on the screen. That's our goal. So what should be next?
Would you see them balance?
One more time. Two people talked at the same time. So tell me again, one more time.
Okay, do you have to write the C out statement, like the instructions to tell them to put the balance in?
Right, C out statement telling the user to enter the balance. Right, very good. C out, enter balance. And then what should be next?
Then you write the C in statement.
C in statement with the opposite arrow, val, that will read the balance into that variable. Very good. Okay. Anybody else? Next step.
You create a new variable to save the balance of the account with interest added.
Interest added, yes. So I need a statement that will calculate the interest and add it to the balance. Yes.
So I did new underscore balance equals balance times 0.8 in parentheses plus the savings balance.
Plus balance. Okay.
But I put the balance times 0.8 in parentheses.
0.08 that has to be.
Yeah.
Okay. You don't need parentheses there.
Oh yeah, I don't need that.
Right. Because the multiplication will be done first before the so that is correct. Very good. So there are some corrections I want to make on that. No, I don't need to make any correction here. Balance times 0.08. This is your interest. Very commonly, students do the math wrong and they assign this to the balance. That would be interest, just the interest being assigned to the balance. That would be wrong math. This interest should be added to the current balance. Only then you have new balance. So this entire statement calculates the new balance. But I want to write it slightly differently because I'm using a constant. So I want to use my constant here instead of the number itself. So I will, that is correct if you write it that way. There's nothing wrong with that. But we want to use this constant name rate created here. So to the current balance, I multiply the rate. This product is only the interest amount. This is equal to interest amount. And if I add it to the current balance, that'll be my new balance. And I can assign that total to the variable new balance like Christine said. That was Christine, right?
Yes.
Yes. So you can either add it to, place it in new balance, but we don't have to. If you don't need to save the original balance, we don't need to save the original balance. So therefore I can put it back in the same variable balance. I don't have to create a new variable. So the variable balance now has the new balance. And so C out balance. Balance equal to, the user should know what the number is. So balance equal to bal. And now it's a complete program that'll get the balance from user and it will write the new balance. Now, common mathematical error students make is writing bal equal to bal times rate. That's wrong math. Bal times rate is only interest amount. So only if you add that to bal, you have the new balance. And you put that back in bal or some other name. It doesn't matter if you use some other name, but this has to be right mathematically. All right, let me quickly ask you an exercise. Variable bal has some number in it. I want to replace it with 10% less. Can somebody tell me how to write that? I want to replace balance bal by another number, which is 10% less than the original number. How do I write that? Anyone? Okay, I'll write that for you. Take balance, see bal times 10% will be 0.1 or 0.10 if you want to write it that way. So bal times 0.10, this is 10% of balance. So if I want to reduce balance by 10%, then calculate the 10%, take it away from bal. So bal minus bal times 10%. Put that back in bal, then you have decreased bal by 10%. There are some homework questions will have similar questions. So I wanted you to be prepared for that.
Professor.
Yeah.
You don't need a parentheses around the bal times 0.1? Doesn't matter?
No, we just learned a few minutes ago that if you have subtraction and multiplication in the same expression, the multiplication will be done first.
Okay.
Okay. So you don't have to worry about parentheses here. You'll do this one. And then,
I'm sorry.
Yeah.
I also just had a different question, but you could finish what you were saying.
Okay. So 10% of balance should be subtracted from balance and put it back in balance. Now, this can be also written as, if I take 10% off from something, that's same as 90% of the original, isn't it? So therefore, it would be correct to write bal equal to bal times 0.9 instead. Calculating 90% is same as taking away 10%. So this will be identical, mathematically identical. Okay, that's all. Alexandra, go ahead.
Going back to the original program that we wrote, shouldn't the constant rate have to be in capital letters, or is that only if it's like two letters?
Yes, you're right. If you write lowercase, the compiler will tell you it should be uppercase. You're right. I was wrong there. So this rate should be in uppercase because your constants should be written with uppercase letters. That is correct. That was my mistake. Anything else? So it should be rate like that. Okay.